how can I predict the graph? And the subtitle is More Graphs of Polynomial Functions. So today we're going to be able to predict the degree, possibly the leading coefficient, and the types of roots that a polynomial has. So today you will use what you learned in the polynomial function investigation to respond to some questions. Thinking about how to answer these questions should help you clarify and expand on some of your ideas about the relationships between the equations and the graphs of the polynomial functions, as well as help you learn how to use polynomial vocabulary. Okay? So for question 822, they want us to use what we know about polynomials so far to make a sketch of the polynomial functions below. Okay, so for A and B, if you have two colors, that's great. If not, just do it in one color. But you know how I had you do the graphs on the whiteboard yesterday with two colors? It's helpful, but it's not necessary. All right, so this one, A is in factored form. We have the factor x plus 10, x plus 7, and x minus 12. So we know that that's going to be a degree of 3, and it has 3 places that we know for sure it's going to cross the x-axis. This one's going to cross where? Not 10, negative 10. This one's going to cross at negative 7, and this one's going to cross at what? 12, okay? So along your x-axis, cross those points and just make sure to label them like, hey, it's going to cross at negative 10, it's going to cross at negative 7, and it's going to cross at 12, okay? How do I know that it's starting down here and ending up here versus could it have gone like that? Well, this is going to bring up something called end behavior, okay? And that works for both. This one's obviously going to be an odd, but it is the same for even. If the polynomial is positive, then the end behavior should be going to positive infinity. If the whole polynomial is negative, the end behavior would be negative. Does that make sense? Okay? And that would determine the starting behavior. All right? B, somehow that minus 8 got cut off. So write the minus 8 right there. And then let's see, this one crosses at negative 6, negative 3, positive 5, and positive 8. The whole function, polynomial, is positive, so it's going to be ending up. And you should switch directions 1, 2, 3, 4 times, right? Okay, that's one that's going to look very much like a W. Any questions on A or B? Let's look at a couple more. Here's C, D, and E. So C is one polynomial that has this little negative sign out front. It's almost hard to see because it's right next to the equal sign, but there is a negative in there, so it's going to end up going to negative infinity, and then we can tell that it's going to cross at negative 4, highlight that. It's going to cross at negative 2, highlight that, cross at positive 6, and positive 10. So instead of looking like a W, this one looks a little more like an M. All right, on D, we're going to have double roots because that x plus 7 is squared and that x minus 7 is squared as well. So what happens at negative 7? It touches the x-axis and bounces off. And then the same thing's going to happen again at positive 7. It's going to touch it and bounce off. Okay? And for E, We have crossing the x-axis at -6, -3, +5, +8, and +12. The whole polynomial function is positive, so we know it's going to end up going to positive infinity as our x increases. Okay? Oh. Are those big enough? Can you guys see them okay? We're good? Okay. All right. Let's move on to question number 23. It says, on the graph, the real roots of the x-intercepts, look back at the work you did in problem 8.2. 8.2 is the one you did in groups. Okay, so some people were in group 1, group 2, and so on. Then answer the following questions. Remember that the roots of a polynomial function are the values of x when it is equal to 0. On the graph, on this graph right here, the real roots are the x-intercepts. So what is the maximum number of real roots a polynomial of degree 3 can have? So 3 roots. They want you to just sketch a random one over here on this one, crossing the x-axis how many times? 3. They want everybody to have a different one. Okay, so just randomly draw one. Then for question B, it says, what do you think is the maximum number of real roots a polynomial of n can have? So that n just represents a number. If it was 4, it would be 4. If it was 5, it would be 5. If it was 6, it would be 6. So just whatever the number is, that's how many roots it's going to have. So question C says, can a polynomial of degree n have fewer than n real roots? And under what conditions? The answer is yes. It's not as common, but sometimes factors are repeated, like in example D. Okay, see how they're repeated in D, so it just bounces off? Or what we're going to end up seeing in this chapter is that some of them will be complex. They're going to have imaginary numbers in them, and they're not going to touch the x-axis. Okay? Anybody still writing? Let me move it up a little bit. Does that help? Good, Rayhan? Okay. All right. Over at the top of page 7. All right. Question number 24 says, examine the sketches of the polynomial functions and answer the question for each. So for little letter I, it wants to know what is the minimum degree. And you're just going to count how many directions it's going. So 1, 2, 3 directions. So the degree is 3. Is it increasing or decreasing? And again, you want to look at the end behavior. Okay? As x is going to positive infinity this way, the y is going to go to positive infinity that way. So we call it increasing. Okay? Double little letter I wants to know what is the minimum degree. This one is going up, then down. So it's just a 2-degree polynomial. And its end behavior is decreasing because it's going down to negative infinity. Little letter 3 has 1, 2, 3, 4 directions. So it has a minimum degree of 4. Its end behavior is going to positive infinity, so we say that it's increasing. And little letter 4 has 1, 2, 3, 4, 5 directions. So it has a minimum degree of 5, and its end behavior over here is going down to negative infinity, so we say it's decreasing. Okay. Any questions on that part? All right. Question 25. For each graph in problem 24, you decided what the minimum degree of a polynomial was, given a sketch of the polynomial. Under what circumstances can graphs that look the same as those in problem 24 represent polynomial functions of a higher degree? So for part A, they want us to consider the graph of y equals x minus 1 squared and the graph of y equals x minus 1 to the 4th power. How are these graphs similar? How are these graphs different? Okay? They have the same base. They both have the x minus 1. So on both of them, they're going to be hitting the x-axis right there at positive 1, right? They're going to have that same general shape, but the 4th power one is going to flatten. Okay? It's going to flatten when it hits, and then it's going to increase more quickly because the exponent is larger, right? When you have a larger exponent, you're going to start increasing much, much faster than you normally would. Okay? Part B says, can the equation for graph of 2 up top here from the problem be a polynomial of 4th degree? And we say, yes, it could be if it had repeaters, right? So if it had an x minus 3 squared, or x minus 3 cubed, or x minus 3 to the 4th, okay? And then the second part of this question says, can it have a degree of 5? And we would have to say no to that one because it would have to turn again. Okay? So we don't have enough turns for it to be a 5th degree polynomial, but we could have repeaters. Right? C, how is the graph of x to the 3rd similar or different from the graph of x to the 5th? They're going to have the same general shape, but x to the 5th is just going to increase quickly, much more quickly, right? Larger exponent is going to go up faster, so it's going to look like it's narrower, but they're going to have the same general shape. And for part D, how do the shapes of the graph of x minus 2 to the 3rd and x plus 1 to the 5th differ from the graphs of polynomials that have 3 or 5 different factors? Bless you. So the different factors have humps, and repeated factors, they more like a bend. Okay? We're almost to the part where we can get you writing something down. Anybody still writing? Go to the next page. Question 26 says, in the first example from the polynomial function investigation gallery walk that we did, we had x minus 2 times x plus 5 squared. The factor x plus 5 is repeated. This is what we call a double root. The squared factor is that double root of the polynomial. So what effect does this squared factor have on the graph? It causes the graph to be tangent at the corresponding x-intercept, and it does what we call bounces. Okay? Part B says that the 5th one, whoever was in group 5, we had negative 0.1 times x plus 4 to the 3rd power is a cubic factor.